Hi, this is Mrs. Tellas. I'm going to go over the first day of 6.1, simplifying expressions involving zero and negative exponents. All right, so anything raised to the 0 power is 1. So I'm going to put a 1 right here. So each of these, because that one is in a parenthesis, is raised to the 0 power. That's 1, this is 1, this is 1, and that was 1. The base is raised to a 0 power, so it's 1. This one over here, you can put it in your calculator or you can do step by step. So 2 to the 0 is 1, and then times a negative is negative 1. Same thing here. 4 to the 0 is 1, and then that negative on the outside is negative 1. All right, and here's where the meat of the lesson is today. Negative powers. If it is a negative power, it can be evaluated by moving the base and the exponent to the opposite part of the fraction. So because I have 7 to the negative 2 here, it makes it an unhappy fraction. So I can move it to the opposite part of the fraction, and when I do that, I copy everything except the negative. This ends up being 1 over 49. Same thing here, it is an unhappy fraction. So I move it to the bottom part of the fraction, which is the opposite, and that's 1 over 32. And it works with variables as well. So since it is a negative fraction, or a negative exponent, I move that to the opposite part of the fraction. And you can't evaluate a because you don't know what a stands for. And the opposite or the complement works as well. So we've got some negative exponents in the denominator here. All of these can be moved to the top. So that will be c to the 8th power. Can't evaluate it, it's a c. Here that goes up to the top, that'll be 9 squared or 81. And this one will be 10 to the 7 or a 1 with 7 zeros. 4, 5, 6, 7. So that's 10 million as the answer. Okay, so we're moving, or I like to think of them as making them happy. So this is an unhappy 7 to the negative 2. He is unhappy. So I'm moving him down to the bottom and reevaluating. So 1 over 49 is the answer. He's perfectly happy the way he is. 8 to the 3rd power, I believe, is 512. Let me check it on my calculator. Yes, it is. So you can put positive exponents, evaluate them into your calculator, no problem. If it has a positive exponent, you really just type it in. This is happy because the exponent is positive. So that is 16. You could just type it in your calculator. He is unhappy, so I'm going to move him to the opposite part of the fraction, which is the denominator. That's as far as I can go. I can't put an X in the calculator. Here I've got multiple questions. So I've got 3, 7 to the 1st, a to the negative 2, and b to the 1st. 7 is unhappy. No, a is unhappy, not 7. So he's going to move. 7 stays, b stays, and a to the 2 goes down to the bottom. So we had 7 and b being happy and a to the negative 2 being unhappy. Here, negative 4 is happy and x to the 3rd is happy. Y to the negative 7 is the unhappy one, which needs moved. So a negative base is not unhappy. He's just negative. And then here, that goes down to the bottom. So that's my final answer. Okay, so I've got some more to try here that are unhappy or happy. This one is happy. This one is happy. This one is unhappy. So he would need moved down to the bottom to evaluate. And this one is unhappy. So he would need moved down to the bottom to evaluate. So 1 over 3 squared, which is 1 over 9. Okay, this one is 16 if you put it in your calculator, and that's negative 16 if you put it in your calculator. Okay, so I have multiple examples here. What I'm going to do is I'm going to highlight the negative exponents and I'm going to make those happy. If there are any numbers, once I make them happy, that I can put into the calculator, I'm going to do that. So 5's fine, a to the 3rd's fine, b to the negative 2 means b moved to the bottom. So 5 a to the 3rd over b squared is the answer. So here I have 2 unhappy ones, this 2 to the negative 2 and the b to the negative 3. They are both going down to the bottom because they are unhappy on the top. A to the fourth stays, 2 squared moves, and b to the third moves. So 2 squared can go into the calculator, that's 4, and the a and the b are already in their rightful place. Here I have an unhappy in the denominator, this one, so he's going to go to the top up there with the y. So that's going to be y to the fifth, x to the fifth times y. Okay, here I've got unhappy here. Everybody else is happy where they are. So negative 3, 6, and c squared stays the same. And this guy, a to the negative 4, goes down to the bottom. Okay, I like my letters to be in ABC order, so I'm going to put the a to the fourth first and the c to the second. And then I notice that this fraction, 3 over 6, you can use your ABC button on the calculator. You can also know that 3 goes into both. So 3 goes into itself once, and 3 goes into 6 twice. So this ends up as negative 1 on top with a 2 on the bottom. I simplified that fraction just like we've been doing for years now. So here this n can be simplified by moving it to the top. So 5a n to the third is my answer. Okay, same thing here. You can't really see this one. We'll go over here. X to the 0, if you remember from that first slide, is 1. So this is negative 12 times 1, which is negative 12. Here I've got a or t to the 0. That part is 1. And I've got an unhappy fraction or an unhappy exponent. So right here goes down to the bottom. So this is 1 over s to the third. And put him down there because he was unhappy. Okay, we've got some other things going on here. He's unhappy, and just the y is unhappy. The 9x is perfectly fine where it is. So I keep the 9x. I'm going to move this down to the bottom, and I'm going to put it in the front since it's a number. And then the y to the third is going up top. So 2 to the fourth power is 4, or 2 to the second power is 4. So y to the third, and 4 times 9 is 36. And that's just an x. That's my answer. These are both unhappy in this fraction right here. So I'm going to switch places. 3 to the fourth power, I believe, is 81. And 2 to the third is 8. And that is a perfectly acceptable answer. We've got a little bit longer one here. So I want to move the m to the negative 1, and I want to move the a to the negative 4. The 5, the 10, the n, and the c are all perfectly fine where they are. So 5, n, 10, c to the 7. Okay, m to the negative 1 is going down to the bottom as m to the first, and a to the negative 4 is coming up top. Okay, the only other thing I see we can do here is its fraction can be simplified. 5 goes into both, so 5 goes into 5 once, and 5 goes into 10 twice. So my final answer is 1 a to the fourth n over t, c to the 7, m to the first. And that first power right there, that's optional, and so is that 1 in the front. You don't have to have those. So on the last one, I have these two unhappy. A stays where it is, and B switches places. I have some more practice here. This big ginormous one right here. Anything to the 0, even something big and ginormous like that, equals 1. Okay, can't see this one very well. I believe that's negative 10, a to the negative 4, b to the 0. Well, b to the 0 is 1, so I'm going to scratch it. A to the negative 4 is unhappy, so I need to move him down to the bottom. Negative 10 is perfectly fine where he is. So that's my answer. Here I've got a bunch of them. Y to the negative 1 and x to the negative 5 are unhappy. And x to the 0 is just 1, so I can just get rid of it. So 11, 3, and m stay where they are. X to the 5th goes to the top, and y to the 1st goes to the bottom to make them happy. And then my very last one is right here. The 1 and the 3 are perfectly fine where they are. And x to the negative 2 is going up top. And this is my final answer there. So I hope this helped. I hope this helped with 6.1, especially if you were absent, that you can see all I'm doing is moving the specific pieces to make them happy. And you can even see here, I should have moved the S7 to the negative 2, the B to the negative 3, and the C to the negative 3. And you can see over here, this is error analysis, and he did not, whoever this is, did not do this correctly. The A should have stayed on top, and the D should have stayed on the bottom. But the 7 should have moved down, the B should have moved down, and the C should have moved up. And that didn't happen in the answer. So I hope this helped. I'm going to put this on my Canvas page, and if you were absent or if you're struggling with it, you can watch this video again. Thank you very much for listening. Goodbye.